Good day, Bayaw. Today, we have here another problem to solve from the book of Thermodynamics by Singal, Chapter 11, Combined Conduction and Convection Heat Transfer. A 1.4 meter long, 0.2 centimeter diameter electrical wire extends across a room that is maintained at 20 degrees Celsius. Heat is generated in the wire as a result of resistance heating, and the surface temperature of the wire is measured to be 240 degrees Celsius in steady operation. Also, the voltage drop and electric current through the wire are measured to be 110 volts and 3 amperes respectively. Disregarding any heat transfer by radiation, determine the convection heat transfer coefficient for heat transfer between the outer surface of the wire and the air in the room. So first, we will be identifying our given. We have here the length and the diameter of the wire, that is 1.4 meters and 0.2 centimeters. The constant room temperature, that is 20 degrees Celsius. The surface temperature, that is 240 degrees Celsius. The voltage, that is equal to 110 volts. The current, that is 3 amperes. And here we'll be finding the coefficient of heat transfer. And here is the solution. First, we have here the equation of our heat per unit time, that is equal to the energy generated of the object, that is also equal to the voltage times the current. And since we have these two values, we'll be plugging in it in our equation. So we have here the energy generated of the wire, that is 110 volts times the 3 amperes, which will be given as a 330 watts. So to find the coefficient of the heat transfer, we have here this equation. The heat per unit time is equal to the coefficient of heat transfer times the surface area times the uh, change in temperature, which is the surface temperature minus the constant room temperature. And since we don't have that value of our surface temperature, we will be solving it first. So the surface area of the wire is equal to pi times the diameter times the length. So it is equal to pi times 0.002 meters times 1.4 meters, and it will give us a surface area that is equal to 0.00880 squared meter. In this equation, we'll be plugging in our values. We have here the 330 watts over 0.00880 squared meters times 240 minus 20 degrees Celsius, and we have here our heat transfer coefficient, that is equal to 170.5 watts per square meter degrees Celsius. And that is our final answer.